Right, anytime we're staring at this 2 square root scenario, I think it's always worthwhile to remind ourselves of, if I'm ever staring at something like this where it's a plus b quantity squared, in class we learned a shortcut of a squared plus 2ab plus b squared. Now you can FOIL it out and you can kind of remind yourself of that pattern. Always amused. Students are always asking for shortcuts, and as soon as I give it to them, the last thing they want to use is the shortcut. But anyways, that's another conversation for another day. All right, so in this problem, I'm going to bring over the square root. So I get the square root of 4x plus 5 equals 2 plus the square root of 2x minus 1. Okay, and then this is where I'm going to square both sides. And then this is where my pattern actually comes in. On the left, I have 4x plus 5. But on the right, I'm going to get something squared plus 2 times something plus something squared. And then I'm just going to remind myself of what those somethings are. So in the first blank, I have a 2 and a 2, and the square root of 2x minus 1, and the square root of 2x minus 1. And all I did was I applied that little pattern that we had up top there in the black with the a squared plus 2ab plus b squared. Just a little bit quicker so I can see how to simplify this process down. Okay, so now where am I at? Still have a 4x plus 5 on the left. On the right, I have a 4. This would be 4 square root of 2x minus 1 plus 2x minus 1. Then I want to simplify this, or I want to combine like terms where I can. So I can see on the right side, the 4 and the minus 1 give me a 3 plus 2x plus 4 square root of 2x minus 1. All right, then let's see, let's subtract 3 from both sides, and let's subtract 2x from both sides. And so on the left, I now have 2 equals 4 square root of 2x minus 1. Okay, so to get rid of the square root, I'm going to square again. All right, and that leaves me with 4 on the left, and when I square everything, because they're being multiplied, that I'm not going to have to FOIL it. I'm just going to square each term individually. So 4 squared is 16, and then the square root of the 2x minus 1 squared just gives me 2x minus 1. So then I get, let's see, 4 equals 16. I went to the trouble of switching all these colors, and I stopped doing that. Let's see, so 16 times 2x is 32x minus 16. And then I'll add 16 to both sides. And I get 20 equals 32x. So then I want to divide. And so x is, let's see, 10 over 16, 5/8. All right, so from here, I want to square both sides. And we get to use our pattern again, yay! So we have something squared plus 2 times something plus something squared. Now on the right side, I'll just have the 4 squared, so that's the 16 times 2x minus 1. Over on the left, I'm just going to fill in my blanks real quick. So it's a 2x in the first one, a 2x, and then a 2, and then a 2. So if I multiply that out, I get 4x squared plus 2 times 2, so that's an 8x plus 4 equals, and then over here on the right we get 32x minus 16. And let's bring all these things together. So we'll subtract 32x and add 16. Alright, so that's 4x squared minus 24x plus 20 equals 0. Alright, now I'm looking at each of these terms and I can see very quickly that I can take a 4 out. So I'm going to do that. Take a GCF of 4. So x squared minus 6x plus 5. And that I can easily factor. So that's an x and an x. Minus 5 minus 1. Okay, so then when I set each of these equal to 0 and solve, I get x equals 5 and x equals 1. Okay, so we're just going to go up top here and just double check that. So we'll put a 5 in. So 5, let's do this mentally real quick. So 4 times 5 is 20 plus 5 is 25. So this becomes a 5 over here. And that's 2 times 5, which is 10, minus 1 is 9, so this becomes a 3. So 5 works. Okay, so that checks out. So let's replace that with a 1. Alright, so 4 times 1 is 4, plus 5 is 9. So square root of 9 is 3. 2 times 1 is 2 minus 1, so that's 1. Square root of 1 is 1. And 3 minus 1 is in fact 2. Alright, yay! Okay, so both of those end up checking out. So we do get solutions of 5 and 1. Alright, in number 10, we could multiply everything out, but this looks exactly like a U sub question that we've done in class a couple of times. So I'm going to go with that approach. So I'm going to set U equal to x minus 1. Then I'm just going to ask myself, what would U squared look like? And that would look like x minus 1 squared. And then I'm going to replace the x minus 1 and the x minus 1 squared with u and u squared. So this lovely quadratic transforms itself to look like u squared minus u. Sorry, I teach statistics, so I have a hard time with u. I keep making them look like mu's. So u squared minus u minus 6 equals 0. And then I want to factor. So u minus, let's go 3 and 2. Yeah, negative 3 and a positive 2 will give me that. So I get that u is equal to a positive 3 and a negative 2. Now, I didn't do all this work to find u. I actually want to find x. So x minus 1 is equal to 3, and x minus 1 is equal to negative 2, and then solve from there. So I get x is a positive 4 and a negative 1. All right, number 11, I can see that I can factor out an x from each term. So that's going to give me x squared minus 9x plus 14 equals 0. And I can see that I can play around with the numbers to get this to factor. So 14 would be 7 and 2, so minus 7 and minus 2. And then I end up with actually 3 solutions. So I get x equals 0, x minus 2 equals 0, and x minus 7 equals 0. So my 3 solutions are 0, 2, and 7. All right, at number 12, we absolute value is we want to get rid of the absolute value symbols. We want to set it equal to positive 10 and negative 10 because there's going to be 2 solutions for this. And then we end up solving each equation independently of each other. So turns out we do the same operations. We just end up with different numbers. So here I get 2x equals negative 9. And here I get 2x equals, oh wow, just realized that I did not, hold on, forgive me. All right, that's positive 10. How about 11? We like 11 better? Okay, so I get 2x equals negative 9 and 2x equals 11. And then divide by 2 in each case. And so my two solutions are negative 9 halves and 11 halves. All right, so in number 13, we're going back to a literal equation, and we're asked to solve for a. In this case, sort of general strategy, I'm going to find a common denominator, and then I'm going to rewrite this in terms of that. Well, actually, let's do this. Let me add the 1 over b. So let me move the b over. So it's c plus 1 over b equals 1 over a. And then I'm going to, so if I had the left side to be a fraction, then I could just do the reciprocal of 1 over, I just do the reciprocal of both sides and I'd be done. So I just need this c to multiply by something so it has a denominator of b. So, and that would be b over b. And so that means I have a fraction with cb plus 1 over b, since they have a common denominator, and that equals 1 over a. And then I'm going to reciprocal both sides in this case. And so I end up with a equals b over cb plus 1. And so now I was able to isolate a out. Number 14, c, which is my goal, is buried deep inside these parentheses, and there's a lot of other operations going on here. So the first thing I notice is I got that minus d. I'm going to go ahead and add it to both sides. So I'll keep the a by itself, or keep the a where it is, and rewrite that as plus d. And then I notice that I've got an a on the times b plus c. So if I divide everything by a, that'll give me b plus c equals this lovely fraction. And now I can see that I'm almost done. If I just get rid of the b, well, in that case, then I just want to subtract off b. So c would be e plus d over a minus b. And that's a perfectly fine answer. Unless we've got a reason to do common denominators, there's nothing wrong with that. So I'm just going to stop there.